So we have an adhesive that can stick very well to wet surfaces. Okay, it's very strong, biocompatible. So it's got huge implications for the biomedical area, dentistry, surgical, veterinary, where adhesives exist, but they're either highly toxic, so you have to avoid certain organs, certain parts of the body and children, or they don't work. We're looking towards replacing sutures and stitches. But what I noticed about Dublin is it's very damp and the conditions are very mild. So there was green algae growing all over the streets and building facades, and I thought that was really interesting. The algal adhesives, they put out a very, very small amount of adhesive, and in that adhesive is a very small amount of protein. Here's actually a patch of what we typically would look at. And you can see here there's the algae attaching to the wall, and they're sticking really well. So this is a good example of the type of organism that we're looking at that produces these amyloid-based adhesives. The protein nanostructures are called amyloid fibrils. These amyloid fibrils are very well known because of their implication for human disease, such as Alzheimer's, Parkinson's, type 2 diabetes, etc. The public is starting to change their perception of amyloid being only bad. And that's due to emerging literature at the moment that there's many forms of amyloid which are very useful in the human body, such as templating melanin and storing hormones. Marine science in a nanotechnology lab is actually very unusual. Without the tools of nanotechnology, such as atomic force microscopy, we wouldn't have been able to explain why amyloid was so useful in an adhesive in nature and why it would be so beneficial for us to use that. We keep invertebrate animals in these small tanks, such as starfish and other sorts of things that put out adhesives in the marine environment. But these are the sole, and they have a parasitic worm that grows around their gills. It's a fish skin parasite, and it has the same mechanism for adhesion as that algae that I showed you outside. The difference is this is a temporary adhesive rather than a permanent adhesive like the algae. So the beauty of that is we're actually able to tailor our end product, whether it's temporary, permanent adhesive. And it's a biomimetic project. It means we're not harvesting that adhesive straight from that living organism, because they put out such a small amount that would be virtually impossible to do. What we need to do is scale up that protein. And how we do that is we isolate the protein, determine what it is, and grow it up inside another organism. For example, inside bacteria, harvested at the other end. These adhesives are produced not only biocompatibly, but no VOCs, and there's a lot of legislation at the moment to reduce VOCs, the volatile organic compounds, right, in nature, so they're environmentally friendly. It's unlikely there'll be a public or political backlash to using amyloid-based adhesives as a surgical adhesive. We could well be upsetting the suture and staples industry.